Hey everyone! So, oh, sorry about that. Really excited to say hey. Alright, solving with natural logarithms. I want to talk about this today. So, let's say I want to solve an example with natural logs. So, here's our example. And let's say we want to solve our given equation, which is 2 natural log of 5x is equal to 6. Right? Your goal is to get x by itself. Okay, so let's get x by itself. First things first is get rid of all coefficients or anything that's being added to our natural log or anything to x. So in this case, we have a 2 in front of the natural log, which has our x inside of it. So let's get rid of that coefficient 2. So it cancels out on the left-hand side, and we have the natural log of 5x is equal to 6 divided by 2 is 3. Okay, now we kind of have a problem here. Natural log of 5x is equal to 3. Okay, so let's go off in a little bit of a tangent here. I'll write it with another color. So we said that if we have like a natural log, so I'll use the natural log or any log base you have a natural log of x is equal to the natural log of y. So this is very similar to log base b of x is equal to log base b of y. We had this property, and then we said that the insides equal each other. X is equal to y. We can set it equal to each other. Alright, the same property applies if you have the natural log because the bases are the same, so you can say x is equal to y. Alright, so I'm going to work backwards in this instance. Alright, now I have the natural logs. However, I don't have a natural log on my other side with the 3. Alright, so now let's take a step back. I know that I can change this into an exponent form. I can change the natural log of 5x into an exponent form. So instead of working with logs, what if we worked with the exponent form, which is the base e of x? Alright, so if you have e, as long as you have the same base, alright, so remember this rule, if we have the same base on both sides, then we can set x equal to y. Alright, the same base being like if you have, what was it? We had, let's say you have 5 to the power of x is equal to 5 to the power of y, then you could say that x is equal to y. Right, you could say. So and you can also do that to the base e power. Alright, and you can also work backwards. So if x equals y works, then you can actually add any base of your own and set it equal to each other. So here's what I'm going to do here. I'm going to work backwards. So I'm going to have them have the same base. So it's e to the power of, so let me write it in our original color. So e to the power of ln of 5x is equal to e to the power of 3. Now the reason why I have base e on both sides, why I'm going backwards in this instance, is because, so let's go off on another tangent. Right, so basically you can work backwards with your properties of logs and properties of equalities for exponential functions. So this was like another, this is from previous properties. Whoops, I'm spelling in different forms. So this is from previous properties. And then let's see, why do we have e to the power of ln? Well, remember when I told you that log base b of x is equal to the exponent? Alright, this is synonymous to b to the power y is equal to x. Okay, now what you're doing is this is equal to the exponent. Okay, natural log of 5x. So you have it doubled in a sense. So you have e to the power of natural log of 5x. So you're like saying e to the power of its own exponent, which basically means that now you can take the 5x down here. So it's kind of repeating itself, and then you can just put the 5x itself down here. And then you have 5x is equal to the e to the power of 3. Now the e to the power of 3, let me write the 3 down a little bit more. That doesn't change because nothing's happening on the right-hand side. But on the left-hand side, when you take e to the natural log, all right, because it has the same base, that's why. Because it's e to the, basically you're taking e to the log base e of x. Okay, well then you just bring x down. So basically the rule says if you have, so let me write my rule in another color. If you have e to the natural log, because it's the same thing, that's just x. Because you're doing it double, and then you're just going to get the value that's inside of the natural log. It's e to the exponent of e. Right? Too repetitive, so when you put it, basically it's its simplest form. Okay, I know I'm rambling on, but basically when you say e to the power ln of x, it's equal to x, and that's its simplest form. So here, what is inside here is my 5x, and that's what comes down here. So now I have 5x equal to e to the power of 3. And then finally, you want x by itself, so divide by 5 on both sides. This cancels out here, so now you're just using your Algebra 1 skills. And then e to the power of 3 divided by 5. You can use your calculator to figure that out. So if you round it to 4 decimals, you get 4.0171. Okay. And then this would be your final answer.